Alright, so with any lesson, we always start with our prior knowledge. As we've been reviewing these for weeks now, I would then just quickly go through them, but just checking with my students with the identity property, our inverse property, associate, and commutative. For the identity, just talking about that anything plus the identity, which is 0, will always give us the same number. Anything times the identity will also give us the same number. And the identity is 1, so anything times 1 will always give us our same answer. For the inverse, we always are trying to equal the identity. So for addition, we are adding the opposite. And so that will create our identity, which is 0, and create a 0 pair. For multiplication, we're going to multiply with the inverse or the reciprocal. We know the reciprocal is when we have a fraction 2/3, we're going to completely reverse it. And so we'll have 3/2. When we multiply this, we're going to equal 1, which is our identity. And then just review the associate property and the commutative property. No matter the order for addition and multiplication, the order for commutative property, our answer will be the same, and then with the order and the grouping, we'll still have our same answer as well. So after we make sure everyone's on the same page, we would then get started with solving equations, which we had been doing for a little while, so our students know that we're working to get x all by itself. We're going to use some of our inverses so that we can get back to the identity and create so that we just have x. So we'll start with this problem here. We have negative 2/3 is equal to negative 7 minus 5/8 times x. So we know here we're trying to get this x term by itself, so we need to start with this negative 7. So for negative 7, we know we want to create a 0 pair, so we're going to add 7. So that we're adding our opposite here. We know whatever we do to one side, we also have to do to the other side for our property of equality. And so once we do that, we know negative 7 plus 7 makes a 0 pair. And so we also know negative 2/3 plus 7 is 19/3. Well, since 0 plus negative 5/8 x is the same thing as negative 5/8 x by our identity property, we could simplify this so we just have 19/3 is equal to negative 5/8 x. Well, we want to get rid of this negative 5/8 and just have our 1x. So we know in order to get to our identity of 1, we're going to have to multiply by the reciprocal. So if I have negative 5/8, our reciprocal is going to be negative 8/5. Well, whatever we do to our left, whatever we do to our right, we also have to do to the left, and so we're going to multiply both sides by negative 8/5. So when we multiply 19/3 times negative 8/5, we're going to get negative 152 over 15. And we do know that negative 5/8 and negative 8/5 are inverses, and so by multiplying them, we are going to get back to our identity of 1, and so we just know that's equal to 1x. Well, because this is our identity, we know anything times the identity is itself. Scroll that down. And so we know x is equal to negative 152 over 15. But with any solving equation, we always need to check our work. So we're going to take our solution and we're going to plug it into our original problem here for x, and then we're going to solve and see what we get. So we'll start order of operations. We're going to start with our multiplication. So we're going to multiply these two and get 19/3. So now we want to solve on the right side. We have negative 7 plus 19/3, which we know is negative 2/3. Well, since negative 2/3 is equal to negative 2/3, we know that this all works. But let's try with a little more complicated of a problem. So now we have our our different part here cubed. So we're going to take this quantity here and cube it. So we need to start talking about this. So we need to get this x term by itself. And so we want to start with this negative 4. Well, in order to get rid of a negative 4, we want to make a 0 pair because we aren't getting rid of it. We're just trying to change different values. So in order to create a 0 pair, we're going to add the opposite. Our property of equality, we know of what we do to one side, we also do to the other. So I added 4 to both sides. By negative 4 and a positive 4 are opposite, so we're going to create our 0 pair. And so we now have the quantity of x plus 3 cubed plus 0 is equal to 11. Well, we know from our identity property that anything plus 0 is itself, and so we could just rewrite this as the quantity of x plus 3 cubed is equal to 11. Well, now we got to talk about this cubed, and we have to talk about what could undo a cube. What is our inverse of a cubed? The inverse of cubing something would be taking the cubed root. So what we're going to do here is we're going to take the cube root of this quantity, and because whatever we do to one side we have to do to the other, we're going to take the cubed root of 11 as well. So we're going to sit here, we know that these are inverses, so they are going to undo each other, and so we have x plus 3. And then if we use our calculator, we know the cube root of 11 is 2.22. Well, now we still want to have x all by itself, so we have this positive 3 here. We know in order to undo the 3, we have to add the opposite. So whatever I do to our one side, we're also going to do to the other. So I'm going to add negative 3 on both sides. And here we know 3 and negative 3 are opposites and create a 0 pair. And then using our calculator, 2.2 minus 3 is negative 0.78. Well, by the identity property, anything plus 0 will actually be itself. And so we are finished here. Sorry about that. Move this down. And so we know x is equal to negative 0.78. Well, just like before, we always want to check our work, and so we're going to take it here and we're going to go back to our original equation and we're going to plug in negative 0.78 for our quantity of x. So here, parentheses, we always start with in our order of operations, so negative 0.78 plus 3 is 2.22. Next, we're going to use our exponents, so we're going to take 2.22 to the third power, and if we do that on our calculator, we know it's 11. So now we're going to finish here with our subtraction. We have 11 minus 4, and we want to see if that's equal to 7, and we know it is, and so this is our solution. So here we can use our different properties to even solve complex equations rather than just our basic ones.